Many manufacturers have turned to electrically powered engines, but is this possible for all automakers? For a company like JCB, which specializes in the manufacture of engines for heavy machinery, electric engines are just not good enough. This is because electric engines are incapable of producing the kind of power these heavy machines require. Replacing diesel engines with batteries in heavy lifting equipment will amount to sacrificing power for less environmentally harmful emissions. And quite frankly, other brands can afford to make that sacrifice, but not JCB. Certain activities, like construction and agriculture, require machines with power. And that's a fact. So, JCB acknowledged the need for a peculiar solution to their dilemma. They realized they just had to make environmentally friendly engines by some means, but they couldn't afford to sacrifice the power of their engines. To do this, in 2020, JCB started working towards developing hydrogen-powered engines with similar power potentials as diesel engines, but that were environmentally friendly this time. Now, barely a few years down the line, even though JCB is yet to commence the mass production of hydrogen engines, they have made immense progress. For JCB, hydrogen engines are the future, and they are championing this course. In this video, we will take a look at JCB's hydrogen engine. We will also examine why JCB has opted for hydrogen as the fuel that powers its engine of the future, the benefits of hydrogen over diesel engines, and how much impact this invention will have on drivers. Electric engines can power small machines that do not require immense amounts of energy. Advancements in technology, like the manufacture of electric cars, have proven this. But what we are yet to see are electrically powered heavy trucks, and that's simply because heavy machines like the type manufactured by JCB have higher energy needs that battery power won't be sufficient to meet. To provide this amount of energy via the EV route, these machines will have to be fitted with giant-sized batteries. The physical space required to carry these batteries and the additional weight this would require make it impracticable. How do we know this? To arrive at this conclusion, JCB had previously experimented with several diesel alternatives. In 2019, JCB fitted a fuel cell supplied by Nissan in a prototype 20-ton X-Series excavator. After a series of investigations, the company concluded that battery cells were too complicated and expensive for heavy machines. From JCB's findings, using these fuel cells would result in the cost of these machines going up to almost 3 times the cost of regular diesel machines. Running costs were also not excluded and were projected to shoot up considerably, making these battery-powered heavy equipment too expensive for customers if at all they were to be made commercial in the end. So with JCB's aim still set on achieving zero net emissions, JCB began the development of its hydrogen engines. Tim Burnhope, JCB's Chief Innovation and Growth Officer, stated that there is a big difference between a car and a machine and that JCB deals with machines. For Tim, JCB has to seek solutions that take both their machine and target market into consideration. And considering the fact that even though electricity might be the most popular diesel alternative, it isn't the only alternative to fossil fuel, we can't help but agree with Tim on this. Initially, JCB set out to convert diesel engines to hydrogen engines. In the process, they found out that conversion wasn't going to function well. They later abandoned the idea of modification, going back to first principles to produce 100% hydrogen combustion engines. JCB wanted to produce hydrogen engines that would match diesel engines in efficiency while producing zero greenhouse emissions in the process, and this wasn't going to come easy. But after 2 years and over 50 prototypes, the company has finally arrived at a patent they are satisfied with. Physically, the JCB hydrogen combustion engine doesn't look much different from diesel engines. Drivers wouldn't notice any difference when driving. And according to Ryan Ballard, the head of engine development at JCB, the only thing drivers might notice is that the engine is less noisy, which is a good thing. By the way, the new hydrogen engine has the same torque as a diesel engine, meaning it can generate enough power to handle difficult conditions. Its peak efficiency is however slightly higher than in diesel engines. We expect that JCB engineers worldwide won't encounter too many difficulties when working on hydrogen engines, as they are quite similar to diesel engines. In fact, the capacity and bottom end of JCB's hydrogen engines are exactly the same as those of diesel engines. So how does the JCB hydrogen engine work? In the hydrogen engine, the traditional diesel injectors are replaced with hydrogen injectors and a spark plug. Hydrogen, having a much lower density than diesel, is injected at a lower temperature and pressure compared to what is achievable in diesel engines. Unlike diesel engines, this engine does not auto-ignite, and this is why a spark plug is included in the engine to ignite the fuel. For combustion to take place, there has to be a perfect mix of hydrogen and air inside the engine. According to Tim, this homogeneous mixture is to be achieved in 28 milliseconds. To do this, a high-efficiency turbocharger with low inertia is included to get more air into the engine very quickly. Burning air at a particular temperature can lead to the production of nitric oxide. But with the low temperature and pressure of combustion in the hydrogen engine, these emissions will not be created. Ultimately, the hydrogen engine is a much cleaner alternative to diesel engines. There is zero carbon combustion inside the engine, leading to zero CO2 emissions. What do you guys think about this? Comment down below.